Why did the biology teacher break up with the physics teacher? Because they had no chemistry. Algebra 1, Lesson 5-6, Parallel and Perpendicular Lines. Learning targets. I will be able to determine whether lines are parallel, perpendicular, or neither, and write equations of parallel lines and perpendicular lines. As a warm-up, we'll answer a couple of questions. First, can you draw two lines that will not intersect? Think about it. How could they possibly not intersect each other? Secondly, can you draw two lines in such a way that the intersection forms four congruent angles? And of course, angles are the amount of rotation that we have gone through in a circle between two lines, or rays in this case, with a common vertex. We'll talk about that in class, of course. And remember, just as a reminder, the video lessons aren't the lesson. They're a preload for what we'll learn in class and then go over homework. Parallel lines. Lines in the same plane that do not intersect, as shown in the graph. Words. Non-vertical lines are parallel if they have the same slope and different y-intercepts. Vertical lines are parallel if they have the same x-intercepts. We have the example, the graphs of y equals 1/2 x plus 1 and y equals 1/2 x minus 2 are lines that have the same slope, namely 1/2, and different y-intercepts. The lines are therefore parallel. Example 1, writing an equation of a parallel line. A line passes through 12, 5 and is parallel to the graph of y equals 2/3 x minus 1. What equation represents the line in slope-intercept form? So remember, slope-intercept form is y equals mx plus b. So we're given the point 12, 5, which acts like our x and y, and we have slope 2/3. So we're going to plug those values for x, y, and m into the equation for slope-intercept form and solve for b. So y was 5, so y is 5 equals the slope, which is 2/3, times x, which is 12, plus b. And we note that 3 goes into itself once, 3 goes into 12 4 times. So I have 5 equals 2 times 4 plus b. And so 5 equals 2 times 4, which is 8, plus b. If we subtract 8 from both sides, we get -3 equals b. So I have the slope, I have the y-intercept, so I put that all together and I get y equals the slope, m, which is 2/3 times x plus b. So many of you will write a plus and a minus and make sure, of course, that you have that parentheses if they're two consecutive operations. Or you can note that negative times a positive is a negative. And so you have y equals 2/3 x minus 3 as your final answer. Another key concept, perpendicular lines. Perpendicular lines, lines that intersect at right angles. Remember, a right angle, you think about one whole circle being 360 degrees. A right angle is a quarter of that, and 360 divided by 4 is 90. So right angle is a 90-degree angle, or a quarter of a rotation through a circle. That's what it means to be perpendicular. In words, two non-vertical lines are perpendicular if the product of their slopes is -1. A vertical line and a horizontal line are also perpendicular. As an example, the graph of y equals 1/2 x minus 1 has a slope of 1/2. The graph of y equals negative 2x plus 1 has a slope of negative 2. Since 1/2 times negative 2 equals negative 1, the lines are perpendicular. So I'll just point out another way of saying that is two slopes are perpendicular. If when you multiply one of the slopes times the other slope, the first times the second, you get negative 1. And that determines that you have perpendicular lines. Classifying lines. Another name for when you multiply two numbers and get a negative 1 is opposite reciprocals. So opposite reciprocals, two numbers whose product is negative 1. All right, are the graphs of 4y equals negative 5x plus 12 and y equals 4/5 x minus 8 parallel, perpendicular, or neither? So we'll remember that parallel means the slopes are the same, perpendicular means when we multiply them together we get negative 1, and if neither of those conditions are true, then they are neither parallel nor perpendicular. So we'll take a look at the slopes first. So the first thing we have to do is get y by itself and put the equation in slope-intercept form, which is y equals mx plus b. So we'll divide all three terms by the multiplier of y, which is 4. 4 over 4 is 1. So we get y equals negative 5 over 4x. 12 divided by 4 is 3. And so that yields a slope of negative 5 over 4. Now we'll notice in the second equation we have y equals 4/5 x minus 8. That gives us a slope of positive 4 over 5. So if we call the first slope we found slope 1 and the second one slope 2, we'll note that m1 times m2 is negative 5/4 times positive 4/5. 5 over 5 is 1, 4 over 4 is 1. I got a negative, so I end up with negative 1. And so lines are perpendicular. Another way we can write perpendicular, because it's just such a long word, is actually an upside down T. That is the actual math symbol for perpendicular. So I'll probably be using that for the rest of the way. Example 3, writing an equation of a perpendicular line. Find the equation of the line passing through the point negative 3, 1 and perpendicular to the graph of y equals 1/3 x minus 1. So here I have x1 and I have y1 if you like. And the equation I'm given is, for this first line, is slope 1/3, y equals mx plus b. If we wish the slope to be perpendicular, a rule we have is that perpendicular to its negative reciprocal. Reciprocal means flip the fraction. So perpendicular lines are negative reciprocals. And so the first slope equals negative 1 over the second slope, which just means flip the fraction, whatever it was. So I know the slope that I want is really negative 3 over 1 or negative 3. I have the point x1, y1, so I can use point slope form, which is y minus y1 equals m times x minus x1. So I'll substitute those values in. I have y minus y1, which is 1, equals the slope, which was negative 3, times x minus x1, which is a negative times a negative 3. I'll do one step that simplifies that. And there we are.